All right, welcome everyone to our Grasp on Robotics seminar. My name is Mark Yim. I'm the faculty director of Grasp and the host for today's talk. Just as a quick reminder, we've got previously recorded seminars on YouTube and you can access from our website. If you're joining us by Zoom, please submit questions through the Q&A button. Don't use the chat. If you're here in person, we'll have an opportunity to have questions at the end from our panelists. We've got two student panelists who will be running the Q&A session at the end. There's Diego Caparel and Devin Carroll. Both are about to graduate, maybe in the next 3 to 4 months, hopefully. So Devin is my student working in robotics, and Diego is working with Dan Kodachek. So I'd like to introduce our speaker, John Suh. John is currently a VP at Hyundai. As many of you might know, Hyundai has started to make a big effort into robotics recently with the purchase of Boston Dynamics and the start of this new AI center that's somehow focused on robotics. John is also part of this robotics effort that from Hyundai, it's separate from the recent acquisitions. He's ahead of this new thing called the New Horizons Studio, where they're developing cars that are robotic to some extent. So John is really interesting. I met him several decades ago when he was doing his PhD creating ciliary arrays for MEMS, which was at the time pretty revolutionary. I think it was very cool. He then worked at Xerox PARC with me on modular robotics. And then he went on to do several startups, again with MEMS and wireless technologies. Later, he then went to GM, where they had in Silicon Valley, they had a effort into looking at new technologies as startups, and that ultimately went to their GM Ventures, where they're doing like venture capitalist type activities. From there, he went to Hyundai, where he's currently at. Again, initially with the venture capital stuff, but now more on the technology development. So please welcome John.
Thank you. So yeah, good morning. As Mark mentioned, he used to be my boss just out of Stanford, working on a really cool project, which I'll tell you just briefly about. So Mark, good to see you, and thank you for providing me here. Thank you for coming as well, and thank you for those that are joining online on Zoom or YouTube. So today, I'll be talking about ultimate mobility vehicles, or what happens when you combine robotics to car design. Before that, I'm going to talk about, I think it's important to talk about some of the backdrop, or the where is the automotive industry moving towards? And that's really the first part. So it's not necessarily to my group alone, but really I think the broader aspects of what is automotive. I think it's important to talk about at least a few of those things from my perspective. And then because my team, New Horizons Studio, is pretty new and there's not much out there on the web about it, I think it's important to share with you how we came to be, right, in a big corporation like Hyundai Motor Group. I think it's important to kind of share kind of how we came to be and kind of what we're thinking about in really broad sense. And part 3 is really specifically about ultimate mobility vehicles, what we're developing, and kind of where we're at. I'm obviously from industry, so there's maybe less math. There's no math in this presentation, right? There's no equations. But I welcome any kind of questions, whether business, design, technical, et cetera. So I welcome any questions about that. So I'm going to begin with part 1, this idea of what is the future of mobility, or another way of thinking about it, what is mobility in the future? And I have kind of 6 perspectives on this, and these aren't necessarily the only things happening, but I think these are things to kind of keep in mind. So I think the future of mobility is about vehicles that are designed for automated assembly, or what we might call lights out manufacturing. This is really important because as you may know, the assembly line was developed or really introduced in mass by Henry Ford in the 1920s. Let's say, and by and large, it's about the same. There's obviously new machinery, new equipment, et cetera, but the method and the mindset that which assembly line is designed is about the same. What is, I think, going to really change though is the thinking about at the design phase, how you make that or how you assemble that vehicle with completely by robotics, and to get to what we might call lights out manufacturing. So really no people on the assembly line. And it really requires, it's not just a matter of making great robotics and the ability to do path planning and whatnot, but it's really at the design stage, how do you design that thing for being assembled by a robot? And that's really, really important because you get a lot of benefits. One, you get a potentially drastic reduction in the footprint of that facility. Tesla announced these are some numbers from Tesla. In fact, they had, I think, a 40% reduction in floor space and by 50% in production costs, which is an enormous percentage. Typically, we might be talking like 1, 2, 3, 4%, if that, any given year. To talk about 50% is a pretty tremendous difference. So I think this is going to be really important as we move into cars of the future. So again, lights out manufacturing, a smaller footprint, and then reduced costs. Number two, obviously, I think battery electric vehicles are really, I think, becoming into the mainstream at this point. I think there are a lot of examples of that. I won't talk too much about that, but fuel cell electric vehicles also, I think, have a role to play. Less popular here in the US, but I think other parts of the country also, I think, looking into it, especially if you think about trucking and shipping and other large vehicles, not just land vehicles, but trains and ships and so on. And this is a bit of an advertisement. This is a concept car called the N74. It is a performance car. It is a fuel cell electric car, so it is a high performance machine that has a fuel cell electric powertrain. So if anything, exciting future for across the board, whether you're battery electric or fuel cell. I think there's going to be a tremendous kind of golden age of design, new golden age of automotive design. But the thing I want to mention here is the bottom part is that the story is also equally about infrastructure, right? You have to add in or replace what might be liquid fuel infrastructure with the electricity in the grid, generation, distribution, and so on, but also hydrogen generation, right? And I think that's one of the biggest drawbacks right now of fuel cell is that hydrogen infrastructure is challenged. But as it were for battery electric, like many years, 20, 25 years ago, almost nothing. Right now, there's more and more can be done, but infrastructure is really, really important. Obviously, autonomous driving is going to has been in the research at least since mid 2000s, and certainly I think coming into more and more. I think there's a debate, how and when, and I think it's a matter of time, so to speak. But it's hard to pin down exactly right what that is. But I think more importantly than maybe the technology is that you have now this sort of question of like, what can a vehicle be, right? You can design now what we're calling purpose-built vehicles that are made for different kinds of purposes, right? It's a kind of public transportation, but it's a moving space. It can be transporting goods, equipment, maybe it's a mobile services vehicle, right? Instead of you going to a place, maybe the place comes to you, right? So through automation and so on, that now becomes perhaps more economically viable. And so for me, automated driving is as much of a really fascinating technology story as it is about how might we reimagine mobile living experiences, right? It is transportation, yes, but it's also about how we think about how we live and how the things that we need are moved about, around us. So kind of rethinking that, I think, is a great opportunity. And not just on the ground, but there's also what I call advanced, or all those are called advanced air mobility through things like vertical takeoff and landing aircraft. Doesn't have to be, but that's certainly, I think, where the primary effort is going on. This is a cartoon picture illustration of a would-be future, right? The ability to have vertiports in an urban center that you can go to and from, one point to another, to not just on the ground, but through the air, And then on the ground, you have, again, services or automated vehicles to get you to that last mile, if you will, to your final destination. And I think what's driving this push now, I mean, there's certainly and everything's a technology readiness that has to happen. But there's always been this view of we'll call it the so-called 30-minute city. So any place that you can go in you know, the first half of your journey is ideally 30 minutes or less, right? And so when you have more than 30-minute commute, which is a lot of us, I think, still, or you actually would wish it was less, right? When it's 30 minutes or less, actually you feel pretty good about it. When it gets above 30 minutes, you feel a little bit stressed out. Now with COVID, working from home, I think it's changed the equation a bit. But nonetheless, this idea of a 30-minute city, I think, is somehow ingrained in our being that we'd like to not just travel 1 hour per day for work, for school, for education, and so on. And I was just curious about this myself. So I just found a map about Rome, and this one, it happens to have a scale bar. And so if you draw a circle, a diameter of 30-minute walk, you get this, right? And so I don't think this is like predetermined necessarily, like, hey, we're gonna make Rome and we're gonna make it like this size. I think it just turned out that when people are having, and I think this is by and large designed by having foot traffic, right, to get from the center to the edge. Now, it's roughly, it's 30 minutes, right? It's pretty remarkable. And I think this pattern, my understanding, it repeats itself city across city, before the advent of, kind of beyond horse, when you get into motorized traffic, then the city gets bigger, right? And so I think the air mobility gets us closer back to this idea. Now, will it actually do that? I don't know, but I think there's a pressure, if you will, to try to shrink our commute times back to this idealized kind of 1 hour a day, per day. Carbon neutral, certainly climate change is in the press a lot, and every industry, including automotive, has a role to play in that. And so for Hyundai Motor Group, there's a goal to get us to be carbon neutral in the production and the operation of our business by 2045. Right now, this is not. I mean, of course, that's production and operation. It's not. This is the fuel and the energy of the vehicles and how they operate broadly. Right. There's a lot of infrastructure things per region that will influence the actual carbon neutrality. But from our part, from our production and operation of our facilities, getting to carbon neutral by 2045. And certainly there's a lot of, the push toward fuel cell and battery electric will also play a role too. The future of mobility is radical. So what do I mean by that? I think this is kind of leading into my talk, is that we have this idea we have the inclusion of more the roboticization, I'm not sure if it's a word, but roboticization of things, right? And these pictures show, in this case, the locomotion capability is enhanced by robotic legs. And I'll talk more about this in other parts of my slide. And so by radical, I mean robotic augmented design, or RAD, right? And I think robotics is a very interesting term. I think the word itself kind of sometimes in the public sense connotes a certain kind of image of what that is. So I like the term synthetic animation or synthetic reanimation, right? Reanimation being like you take something dead, right? That would bring it to life. But so a machine isn't necessarily dead nor alive, but it's sort of this making it kind of alive. So a synthetic animation, as I like to call it, or robotics for short, right? I think that could be could be kind of a long word. So in summary, again, I just want to kind of recap this first part, that the future of mobility is really, it's changing a lot, right? We're talking about kind of rethinking how we do assembly, about new powertrain, about how does automation allow us to reimagine how we move ourselves or things to us. It's aviation, I think, will play a bigger role, not just ground vehicles. Thinking about how do we become climate minded and carbon neutral to the extent that we can, and then to really think about augmented, roboticized, enhanced design. And that kind of leads me to the second part is really the origin story for New Horizons Studio. And in this second part, I'll kind of talk about how we came to be and the ability to kind of rethink virtually everything about what is a car and how we make it. Just to give a context, so in that sense, the Hyundai Motor Group is self-changing, right? It's trying to position itself from a mere manufacturer, and that's how you can describe us today, to a kind of what we call smart mobility, smart sustainable mobility kind of solutions provider, right? So it's kind of broadening kind of what we do and how we think about it. Now, in this chart, we're showing, I think there's a lot of, in the core competencies, I guess a lot of the traditional important things that we do today, lightweighting, electrification, connectivity, et cetera. And then on the sort of the right-hand side, we're thinking about how do we interface with other aspects of production, as I mentioned, smart factories, so smart manufacturing, cities, the electric grid, infrastructure, eco-friendliness from operations and supply chain viewpoint. And the top part is kind of referencing some of the things that we're kind of branching into, things like robotics, aviation, robotaxi services, et cetera. And then, my favorite, of course, is ultimate mobility vehicles. So I'm really benefiting from the fact that Hyundai Motor Group as a whole is changing how it thinks about itself and what it believes to be important in its own future. So this is how it really began. It really began with a simple question, the single question: what if a car had legs that could walk? That was literally how it started a conversation that I had, and it's an interesting question. Like, what if a car had, and what about it, right? And what would happen? And you're like, well, I don't know, right? And then how would you do it? And why is it useful? Who would benefit from this? How would it work? What are the technologies that are out there? So as with any question, just like in research, questions beget questions, right? And we have a question and you search for a solution that generates more questions. That's why if you're a PhD student like I was, I stayed there for a long time because there's more questions came after questions, right? And that's how it happened. And then what we said is, well, let's look into it. Let's figure this out, or let's at least see what the answers could be and where they could be leading us, right? And so at this point, we're not really sure if we want to do this thing or not. And so I'm going to show this picture here. And actually, I'll put in the middle. In the middle is the work that Mark did at Park. It's the modular robotics project that we did. And it was looking at locomotion, right? And how do you take a robotic thing and change its ability to, what does this mean as a locomotion, whether it's a snake or rolling or walking type motion, right? So this idea of using shape and form to affect locomotion has been around for a long time. And some of the pictures are showing things back in, I think, 400 or 500 BC. This idea, this mechanization of quadruped, right, has been in the minds of humans for a really, really long time, right? It's definitely not a new idea. People have been thinking about it. That's a toy, I believe. And there's patents from the 1800s, or actually, 1900s. That's a patent drawing, right, of a mechanized horse. And then I can't remember when that. It looks like a toy for a kid, but it is a quadruped, right? So again, this idea of thinking about quadrupeds affecting it in reality has been around for a very, very long time, and it kind of continues to this present day. In the picture on the upper right is a excavator. Really fascinating. There's a lot of videos. If you see videos about this thing, it is fascinating. It has this articulated. It is actually, I think, one instance of a roboticized, in this case, excavator. The wheels have 2-3 degrees of freedom to enable it to do work on very steep side slopes, and so on. So the videos of this machine are pretty incredible. And of course, science fiction remains this ongoing set of examples of what these vehicles can be. And this is some cartoons from Star Wars. And so every time I look around, there's this idea of how do you convert from wheel to leg back to wheel again, or the combination thereof, right? And it is a fascinating thing to think about. And then we said, okay, so what? But is it really necessary? Because cars are highly engineered, right? Proven kind of capabilities, and there's different ways you can modify them to go in different terrains. But it turns out, as these pictures show, the cars get stuck, right? Even the ones that you think are meant to handle terrain, extreme terrain, get stuck, right? And in some cases, it's no fault of their own. There's obviously flooding, so that's going to incapacitate a lot of vehicles. I like the picture in the upper center. Is in Alaska there was an earthquake, I think about 10 years ago, and miraculously this vehicle is just totally intact, right? But it can't move for the fact that the road is totally messed up, right? If this car had legs, could it get over that? I'm not sure, but the idea is that sometimes cars can't move for the terrain, right? Not that they are incapacitated, it's just the terrain and the limits of suspension, the range of suspension is really limiting that particular vehicle, as is the Jeep in the Trev. Now that Jeep, of course, is made to go off-road, right? But given given that, you just can't drive thoughtlessly. You have to be really careful, right, in how you drive that. But in the case you can still get stuck or what have you. That Hummer in the lower left is, I think they probably thought it was a smaller pothole than it is. And this time of spring, we have a lot of potholes, right? And so that can happen as well. Or just sometimes driving into a place that you just didn't think you had to worry about. So soft sand, deformable surfaces can quickly get you stuck. It was the case, I think, of Opportunity or Curiosity on Mars. Like one of the 6 wheels got stuck in sand, and that was it. And then the vehicle couldn't move, and that was end of mission for that vehicle. So one of the 6. So if it could have lifted and moved that wheel to a new location, then possibly that rover could continue on its mission. I like the picture in the lower left because that's like, is it really stuck? I'm not sure, but I just found that picture funny. It's like they're probably like, hey, let's go over this pile of snow, but it gets stuck too, right? So that began the project called Cars with Legs. We just literally called it the Cars with Legs project. We were thinking about what does this look like, what could it do, and then we thought things like in the cases where a disaster scenario could wipes out a road, right? So at that point there are no roads. How do you get to so search and rescue is certainly for us one of the really attractive use cases for a vehicle like this, because in a typical vehicle, it just can't overcome the obstacles to get to a person. So we call it Cars with Legs. We initially looked at electrohydraulics because given even to say extremely high power density in the actuators, actually it's probably number 1 in terms of power density, electrohydraulic actuation. And so, but we didn't. I think it's some of the system issues with hydraulics, I think, caused us to not really look at that for too long. But as we kind of as I mentioned, when you have a question like, what do you have if you have cars with legs and can walk, it sort of begets other questions. And part of it is like, well, it'd be helpful for those that can't get to places. So those with maybe some physical disabilities. And one of the things that came across that was this idea of universal design. And I bring this picture up here. It's a curb cut, so there's nothing too special about that necessarily. But universal design was something that we thought would be great if we could include the concepts of universal design to be inclusive for the broadest set of people. And if we could, that would be great. And what's interesting about universal design is that it is applicable to not just people, but robots, right? So this whole category of sidewalk robots was much more possible with a curb cut, right? Because if you don't have a curb cut, and if you have a vehicle like that, it's just the range of suspension and the wheel diameter makes it more challenging or impossible for it to go over curb. For you and me, it's you don't even think about it, right? But for that, it would be challenging. But now with curb cuts, then you make it available. So we thought, well, what could we do to make vehicles like this more inclusive? So we thought, well, from the get-go, how do we design the ingress and egress of this vehicle so that you can get wheelchairs in and out of this thing easily, right? And this is what I mean by like when you have a chance to rethink a vehicle, you can rethink everything, right? Even not just its means of locomotion, but how it's designed and who benefits and you know how could we kind of rethink that, right? Rather than retrofitting the vehicle, we can design it from the get-go. So in this case, we have a car in which you bring your own seat, I guess you could say, right? And so we had some design concepts about that. It's not just wheels, it's like it's rolling carts can go in and out easily for different purposes. Here's some sketches about how we think about a kind of ambulance kind of function or cargo. Maybe we have doors on all sides so that no matter where you are in the vehicle, and there's often some structural challenges that make it impractical. But again, this idea of rethinking, how do we think about ingress and egress for people, for things, and so on. Well, then we said, well, in reality, having kind of leg wheel locomotion, the case is more easily made for off-road or off-highway, off-trail mobility. So we came up with some imagery to think about that, and that's kind of where we are today. Is really thinking about off-highway, off-trail, off-road mobility, and that's kind of led us to this thing called the Elevate concept, which we released in 2019. This is and this picture here is much more of a vision, aspirational design. It's not something we're working on directly right now, but it kind of represents, how if we can get here one day would be amazing. Obviously, a lot of difficulties getting there, which I'll talk about in just a bit. Now, much smaller, we took about a 1/8 scale using off-the-shelf actuators and put something together that demonstrated, at least at the 1/8 scale, some of the locomotion capabilities of walking, both in mammalian style, reptilian style, and so on. What was interesting, scale, right? If you think about kind of animal design or so on, scale really becomes like a thing, right? And so for us, the question is, what is the appropriate scale relative to the available technology or projected technology to make a vehicle like this? So smaller is easier, maybe, but when you get smaller, maybe less utilitarian because it's smaller. And then you get larger, more utilitarian, but harder technically to implement. So right now we're trying to figure out the design space, how big, how many actuators, what's the configuration, et cetera. So it's still trying to determine that. We haven't yet determined what the actual scale of the vehicle will be. We have a sense of what that is, but it's still not for us a settled question. The uncrewed version, the model led us to think about an uncrewed version. And so we had a video called Tiger X1, which is out there on the web. And it allowed us now to think about an uncrewed version carrying cargo, equipment, and goods for doing various things, goods delivery, surveillance, monitoring, a science platform, et cetera. And then we thought, okay, well, a vehicle like that would have a hard time getting to a remote location, right? Because if this thing is designed to go to remote, inaccessible areas, then it would take a really long time for it to go from the base camp to its mission site. So we thought, why don't we carry it by aerial vehicle? So this combination of aerial vehicle and ground vehicle is fascinating. I know some of you might be working on that problem. It's a really fascinating combination of the two, using the best of both, right? Using aerial mobility for speed and efficiency to location, having a ground vehicle to effectuate some kind of ground mission, et cetera, and then working two together. So this also remains a bit of a vision and aspiration for us. We're not yet working on this combination, but we believe that the developments and things like air mobility happening today in our vehicle, I think they will converge at some point, not in the not too distant future. So I'm really excited about this one. I talked about earlier in the first part about manufacturing, right? And so additive manufacturing, as you know, is also an emerging technology to some degree, at least in the sense of production, right? And the ability to kind of consolidate design so that you have something that is using the least material for the function, I think it's really a fascinating prospect. So we looked into it, looking into, in this case, off-the-shelf technologies, which aren't necessarily for production, but it helps us to think about how do we use this technology to create, the function for the least material. And not just that, it's really about, for us, everything about efficiency from the viewpoint of like X to mass ratio. So strength to mass ratio, torque to mass ratio, power to weight ratio, everything to weight ratio is a factor. Right? And the question is, how do we use the best in modeling, design, optimization, consolidation of functionality to get the most out of the least, right? And how do we do that in a way that's practical, right? And again, it's a part of the design thinking from the get-go. If you do it later on, then you're not really, I think, taking, you might miss opportunities if you think about additive later on, right? I think if you think of it in the front end is where it really needs to happen. That's one of the challenges overall, I think, the separation between design and manufacturing. In design, you not necessarily have the skill set or the experience in manufacturing and vice versa, right? And I think there's an opportunity to try to bring those two worlds even closer together, right? And it's a topic in and of itself. Another area that was really fascinating for us is carbon fiber reinforced plastics, or composites for short. Amazing material in a lot of ways, but there is a recyclability problem, right? It's like, it's not, right? Right now, I don't think you can recycle carbon fiber. So if this were really to scale up, you have a lot of parts that are in landfills. And this is the, I think, pending problem of the wind turbine industry, right? They have a lot of these blades that you will just somehow put in a landfill, I think, or something like that. So they too are actually thinking about how do you make sustainable composites? And one of the ways would be to think about how might we use plant-based resins and fibers to do that. There's a lot of industry effort. I want to say a lot, but there's definitely an industry effort to look at plant-based fibers, or not just, and it doesn't have to be plant-based, but it could be things that would allow you to recycle these materials after the end of life, one of which is through bioresins. It's not the only way, but that's certainly one way. And then the corresponding technology would be fibers. So there's hemp, there's flax, sisal, and so on that are looking at how do you industrialize plant fibers into yarns and fabrics that are industrial grade, right? That have, which means consistency, quality, known properties, right? That you can engineer to. And that there's certainly a gap there, I think, but I think the most developed so far is flax. And flax you can get into pre-impregnated sheets of flax that you can put into carbon composites, and we have used that a little bit. But on the other hand, it's like the properties of that. How do you engineer that in with predictable behavior? Now, one great thing about the plant fibers is that it provides a greater toughness to carbon fiber, because if you hit carbon fiber today, you might crack it and you'd never know. But with plant fiber, it would actually provide a greater crash resistance or impact resistance. So that's really attractive for things that will be on the road, right? So again, looking at how do we think about scalable composites materials for vehicles is a huge undertaking that we don't have the resources on my team to look at, but there's certainly a lot of effort into that. And now for doing this interesting, weird, expensive vehicle, why would you want to do it, right? And so this book I read, years ago called Purpose-Driven Life, right? And I thought about that. And how do we do purpose-driven design, right? Why are we doing this beyond the incredible technical opportunity that it represents? So, I think of it as technology enables, but what purpose are you doing whatever what we're doing? And I think there are a lot of reasons, and I think among them I kind of highlight here. How do we adapt to a warming world, right? If you have a warming world, there are probably a lot of things that happen with that, and how might our vehicle be a part of this? I don't want to say solution, but the adaptation to a changing warming world. And space resources, right? There is a, at least in the US, kind of renewed push to get to the moon and beyond. So how might we think about the interest in developing space resources for our benefit. So wildfire being one of the impacts of climate related change among many, there are a lot of issues to contend with, kind of shown here. Wildfire season is certainly expanding. Whenever there's been a lot of rain in California this year, which is a double-edged sword because we need water, but then it promotes plant growth, which is good, right? But then if you have a dry year, that plant growth dies and you have a lot of fuel that becomes a fire eventually. So it's this kind of seesaw that I think that we're in for quite some time. But the thing that's happening, of course, in a lot of places, you have people living in and near wildland, and you have, I think, if there's a fire in the middle of nowhere, maybe it's okay, well to some degree. But if it's obviously people and structures, then it's a real issue, right? Livelihoods get impacted, and so dealing with this more and more is going to be an issue. And the people that deal with it are fire crews, and the tools that they have are, saws, axes, chainsaws, and that sort of thing, right? That's basically what they use, right? And so how might we use a ground vehicle to help with, not necessarily the firefighting, but supporting, with vehicles that can go into the terrain and the duration that they need to fight wildfires. That's a question that we have, and I think there's opportunity there. Switching over to space resources, again, there's in the last ever since Apollo, continued research on what's on the moon, the discovery of water ice in the last, say, 10 years. Fascinating kind of development. This is a picture of the South Polar region. They have verified the existence of water ice, and once you have water ice, you can convert that to fuel, oxygen, water, of course, and then breathable air. And so there's been a push there. Now, ground vehicles are going to be needed, right? Because the Apollo missions have shown that once you have a ground vehicle, your ability to travel is greatly enhanced. So there's no surprise there, right? So if you have a car, right, you can go further away. So if you have a car on the moon, you can go further away too. And so the thought is that if we have a vehicle that can go into more places than what the lunar rover did back in the 60s and 70s, it's been that long. But the distances that they've been able to go, it's pretty amazing. So we're thinking about how might we design our vehicle for lunar mobility applications, specifically in area of construction, not just exploration, but really in the area of construction, which I'll highlight in just a bit. And the other reason for being in the moon is not just this is definitely more further out, but the existence of helium-3, which could be a fuel source for fusion, which of course is still a big area of research that's still not settled yet either. But if you can get fusion with helium-3, the excitement about helium-3 is that you have no radioactive byproducts from the fusion reaction, right? So you have this clean, very, very, very clean source of power potentially, right? You're fusing elements, and there's no radioactive byproducts, and so it could be tremendous. And so there's and it's right on the surface. There's a bunch of helium, right? Like within 6 inches of the surface, there's a lot of helium-3 from the solar wind interaction with the surface, and it's just sort of there, and you just kind of scoop it up, and then off you go, and then you have a fusion source. And kind of wrapping up this section, I like to call it this, as I mentioned, science fiction has kind of been a source of inspiration. Of course, lots of things have been in the movies and books and now have come to pass, right? And I have a coming soon section, flying cars, space elevator, FTL, okay? That's probably way, way out there. But I like call it collaborative mobile autonomy, right? And I really think this is where I'm really excited about this robotics in general, about collaborative mobile autonomy, which is a long way of saying how people and machines interact in a natural way. There's all kinds of technologies that are coming together. The funniest example I can give you is a movie called Robot and Frank, came out about 10 years ago. If you haven't seen it, it's really funny. It's kind of a dark comedy. Frank Langella, who's the character here, plays a sort of bank robber who is retired. He has a robot companion given to him by his kids, and he realizes that this robot can help them steal things, right? And so he's a great aid in helping. I think he's scoping out a house, and he does like one more like heist, I think, or something like that. And it's a really funny story. But here, right, it's a picture, literally a picture of how I think this robotics could be with people. I think it can be natural, be part of everyday life. It helps us do things, hopefully not stealing, but can do some interesting things. So I'm excited about this idea of collaborative mobile autonomy, things that move in the world, but safely, right, and naturally in a lot of ways. So with that, I'm going to play a video now, switching to part 3 about who we are as a team. This is will tell us about. Oh, and I just realized there's no audio. Here we go, audio. Oh shoot. How do we do audio? All right. You know what? I might skip this one because there's no audio, and it'll be like watching a silent movie. So I'm going to skip this for now. It is. I'll send you a link later on because it is. Let me get to the very end here. Okay. Next. Okay. I'll send the link to the video. It talks about that kind of a general overview of what we are as a team, and that we're setting up an R&D office in Bozeman, Montana. And Montana is not only a beautiful place, but it's where the future of our team will be headquartered there. So final part, and I kind of breeze through a lot of the slides here, so I definitely want to get to Q&A, and I do hope you have questions for me. And so this part of the presentation will be talking about what we have under development, a lot of pictures, and not necessarily a lot of technical detail, but I'm going to try to get as much detail as I can. And I'll just kind of start with, what we're trying to do, right? We're trying to develop products for future customers who want or need to travel over, terrain that's difficult or impossible with a conventional vehicle. We have the following focus areas. One is called AROMS. It's an acronym, Adaptive High Range of Motion Suspension. That's in effect the functionality of what we're trying to do with roboticized suspension, right? It's an adaptive suspension. Wheeled and terramechanics, right? How the use of wheels and its interaction with soil and rock is really important. Computing and autonomous AI control, incredibly important because we want these to be, again, collaborative, mobile, autonomous things, right? And so autonomous control becomes exceedingly important for us to do that. Energy and power, of course. How do we do clean, eco-friendly power sources, battery and or fuel cell and or hydrogen propulsion systems? The chassis and body technology is really the materials, the manufacturing of that that could be made with an automated assembly, right? And then finally, the design for automated assembly, right? So it's not a technology per se, but it is a thinking, a mindset that goes into all the other things to put things together. Okay. So UMV, Ultimate Mobility Vehicle, it's not a category that you can go on the web and find a car today, but I hope that you will in the future. So we kind of went ahead of it a little bit and called it a UMV. And it's a new product category. Again, it's a suspension, it's a roboticized suspension, and wheels is an electrified platform that's modular, and we're looking at both crewed and uncrewed versions. And I'll start with, but before that, let me talk about a little more like where we think this can be useful. There's kind of 4 big areas: natural resource management and emergency response. There's a lot of things that happen off-road, right? So rangeland management, a lot of the middle of the country dealing with cattle or farming, right, is literally not on the road. I think there's a lot of interesting applications there. Search and rescue, as I mentioned early on, we identified that as a really great area to look at. It really, not necessarily from a market viewpoint, but from the use case scenario, like how do you get into extreme situations and provide mobility in that context is going to really stress and push our design to another level. And I mentioned wildfire fighting and crew support. Next is construction mining. Obviously, there's a lot of work in construction robotics in the building sense, but how do you get up and down stairs and go through a constantly changing environment to deliver goods or provide equipment to workers. Civil infrastructure is a lot, is like the highways, bridges, things that span quite a bit of space. So having a vehicle that can go further and do similar kind of construction work, but across a larger area. And then of course reality capture, which I think is one of the leading applications today, both in construction and mining. It's like what are the changes day to day or even hour by hour of an area to ensure that you're kind of monitoring and measuring the progress of a construction site or a mining operation. Third area is goods delivery. This one, obviously, I think from a robotics viewpoint, probably one of the major areas that we're looking at. So at first, I wasn't thinking about urban delivery, but somebody pointed out to me, there are still a lot of cities where there's a lot of steps. You don't have curb cuts or ramps, right? And I think I've noticed that the cities in the east, compared to the west or southwest, there's a lot of steps, right? That you have to deal with. And so it's like, yeah, okay, that makes sense. And so maybe not to the complexity that we have here, but the ability to have that articulation on the wheels could be really important. Remote access areas, again, areas that are probably unimproved, may not have maintained roads, that can be important. And then first responders, similar to the very picture I showed very early on of a vehicle going into an area where there was a road, right? But then through some event, that road is now gone, right? Or obscured. And that could be really important. You still have a human element, but you're delivering and supporting those humans as they do their work. And then fourth and final is space resources. And this is, I'm really excited about this opportunity because then you have this idea that, there's lots to learn, right, from going to the moon, and then lots to do, right? And then if you want to have a human permanent settlement, not just spend a few days and come back, then you have to build habitat, you have to build infrastructure and so on. So things like how do you create landing pads, habitats, power and data infrastructure, and so on. So it's a huge undertaking that I think is, lots to think about there that I think it could be really exciting. And the fact that there's no roads there yet makes our vehicle, I think, intuitively more sense to be there. So right now we're working on two types of vehicles. One is the smaller uncrewed vehicle. We call it the X1A. It's a micro UMV. And then we have a larger vehicle. We call it mini UMV. Mini from the viewpoint as small compared to your typical car, right? The micro UMV is about 100 kilogram or less vehicle, and the mini UMV is anywhere between 400 to 800 kilograms, which by automotive standards is a very lightweight vehicle, right? The cars are in that 2,000, 3,000, sometimes, 4, 5, 6,000 pound vehicle. So to do 800 kilogram is a lightweight vehicle. Not as lightweight as a Formula One race car, but it is relatively light by automotive standards. So again, the micro UMV is for uncrewed applications and mini UMV is for crewed applications. So this is again to elevate. Again, this is the aspiration that we're trying to move to. And where we are today is still thinking about, I want to show these pictures because it's the idea that we're trying to make a car. We're still trying to make a car at the end of the day, right? Car with roboticized suspension. So in here, it definitely looks like a car, but the roboticized suspension is somewhat hidden, right? And that's the idea that we want to incorporate the aesthetics of the leg design, if you will, or AROMs with the vehicle, right? And the two can play together. So it's still very much a robot. You're looking at a robot, right? But you're looking at in the form of a four-wheeled vehicle, right? This picture here probably shows that a little more visible, like how the AROMs in this case can create a huge change in height, right? And this even for us is very useful because we're thinking, I'm not sure if I want the vehicle to be that tall because obviously your center of gravity is now very high and it will impose problems of its own. But these illustrations even help us think about how high do we want it that high, what's the degrees of freedom, et cetera. So even though they're still conceptual, they still help with our design thinking. Here's yet another kind of look at the styling of this vehicle. So we're still kind of going through these ideas. Now, where we are focused on is what we call the adaptive high range of motion suspension. This is a picture of it's actually a 6 degree of freedom leg, if you will. There's 5 in the leg, and then there's the powered BL. This is just the mechanical assembly of what we have today. With the people there, it gives you a sense how big this is. We have since put it on a vertical, kind of where we're at today at the very moment is on this vertical a test stand. I call it a squat rack. So if you can imagine like going to the gym and there's a squat rack, that's what this is. You can actually add weights. It's not shown that we can add weights to it, and we can test out the squatting strength of this system. Like in human performance, a squat is a kind of a measure of your kind of core strength. And so we're trying to do the same thing. It also gives the ability to design the sequence of motions of the hip, the knee, the ankle, and the wheel to create that lifting motion, right? And so it's not just one joint, it's the coordination, just like in lifting, right? How you coordinate all of your joints makes a difference, right? And your posture and everything. So we're trying to discern that as well. What is the appropriate sequence of torques in each of these, any joint to get us the lifting motion with the least amount of power or the fast and so on. We haven't figured that out yet. That's something we're trying to figure out to understand that better, right? And it'll depend on posture and a bunch of things. And we're not sure if it's 6 degrees of freedom or 5 or 4. That's still also a question too. We don't know if it's a serial chain or a serial parallel mechanism. Lots of questions that we don't know yet. So it's, here now we have the electrical, right? So if you built robots, I'm sure you're really familiar. Once you add wires, it really gets interesting at that point. Same with us, right? Because wires change your degrees, like your mobility, right? Are the wires interfering? Are they twisting? And so we have the same problems too. We're trying to figure it out. What's the appropriate arrangement of the wires? Even where the wire comes out of the actuator. Is it on the side? Is it the middle? Is it through the middle? All those things we're still trying to figure out. So, as I'm sure in your work, you have similar questions, and we kind of have a similar questions too. Maybe if not just a bigger scale. Oh, just finally, the previous picture, right? It just shows you the scale, right? So you can just see how, especially in this picture here, that person, it just gives you a sense, right, of how tall that is and where we're going with it. So it is in fact about as tall as, at least where the hip is, but the height of an average of a person. Okay. Again, some concepts for what that can do. I would want to wrap up with some pictures here of the X1A. So I want to highlight lunar applications. This is some scenarios that we think are plausible. So this is kind of clearing out rocks. A landing site, this is creating a berm for, a berm is something that would be useful for a landing pad to limit the amount of dust that is coming up from a plume, which is going to be more of an issue if you had the larger the rocket, the more plume you generate, and then having a berm is going to be really important. Laying infrastructure. So this picture here has a cable spool in the middle that maybe laying out power cable from your solar or your power plant. This is a kind of a sintering operation where you have a tool. So what's important here is not just the vehicle, but the tools, right? And whether it's a manipulator of one form or another, right? Manipulation is, or tools, right? Really, really important. And here is the ability to reconfigure the vehicle to lower it, right? To again, do certain things. So I think there's a lot of interesting things going on. Finally, habitat building. You can't quite see it, but there's like 4 of these machines carrying this habitat, right? The good thing about lunar is that you have 1.6G that gives it the ability to carry more, right, if you will, compared to Earth. And so because the mass, the torque to mass ratio is really important, it gets better on the moon. So moon would be a great place to have these vehicles. So where we're at today, we have this kind of prototype called the X1A. It's a 4 degree of freedom A-arm structure. We have hip abduction, hip extension, knee, no steering, and then we have a powered wheel. These pictures show just some of the range of motions it can generate. Not too different from any kind of quadruped. The difference being that you have now wheels, and the incorporation of wheels and legs together, I think, is from what I can tell, yes, it's been research on leg and wheel locomotion, but I think there's a lot more that could be done. And I think this is where we could need help in this understanding the dynamics of rolling traction, powered rolling traction, and then leg motion, right? So I think that combination is fairly less research. I think definitely less research than pure quadruped and pure rolling motion, whether wheel or track, right? So I think there's a lot of interesting research to be done in the combination of two, and then the coordination of 2, 3, 4 wheel legs working in concert together, right? I think there's a lot of things. Now, in addition to the locomotion, we have the ability to articulate the chassis. And I'm gonna give a shout out to Mark as well, because we've this idea of reconfigurability and modularity, I've kind of carried ever since my days at Park. In this case, it's a articulating chassis that can go from arch to flat to this tub, right? And do we really need it? I'm not sure, but it's a question, right? It's a question if you could do this, if you could roboticize not just the legs, but roboticize the chassis, what does that give you? And so this is CAD, but we actually developed a physical model of this chassis in the lab. And I don't have pictures of it, but we have developed it. But what this gives us is this idea that you can have different kinds of cargo. You can have cargo that's that the vehicle can kind of roll over and pick up from the bottom. As shown here, you could have different pods to attach and detach from that. You could have it top loading, right? You can have it so that the chassis is more of a tub format, and then the human can then just put something on top and then have it go on its way. So there's different use cases for different shapes, and this allows us to explore these kinds of possibilities. So thank you very much. There's some time for questions. I hope you do, and I really appreciate your interest in coming today. Thank you very much.
All right, thanks, Sean. We've got I think we got one question online, and if you've got questions here, Diego and Devin will handle.
I'll start with an online question here. Have you thought about whether a version of ultimate mobility technology could be applied in personal gear for mobility assistance, i.e. not a car or vehicle, but with helping disabled or elderly individuals walk?
Yeah, on that question about kind of personal mobility, we haven't looked at it a lot. But there is one thing in common that we do have, and it's really on the either direct drive or geared electric actuators. And so I think what I hope, it wasn't maybe totally clear, but these are geared electric actuators, right? And I think through our work, I hope it happens that we make progress in the torque densities or efficiencies in direct drive or geared electric actuators, or gear design, right? And that would help with personal mobility devices. And I think that is helping. That's the one thing for me, and I have a mechanical engineering background, and that to me is the one I've been really sensitive to is the need for yet more progress on geared electric actuators, gear design, and I just been really fascinated by gear design. And the gear design is a art and science and engineering all together, plus manufacturing mixed in with that, and it's just fascinating to look at and think about gear design of all types, right? So not directly with that, but again, I think what we do could be part of that bigger story to improve geared electric actuators or direct drive actuators that would help with that. Right?
Thank you, John, for the talk. So I have a question about on the operation side. So it seems that the design has a lot of similarity with Spot Mini and with Handle, right? So it's wheeled and it's legged and it's like a, like quadruped with wheels. So so do you guys talk to the Boston Dynamics teams, or like so what's the nature of operations when you like decide on the decisions here?
So it's a question that how and so our interaction with a company like Boston Dynamics in particular, and the short answer is right now we're kind of focused on each in our own areas, right? They're obviously part of the Hyundai Motor Group, right? And it's a really important part of Hyundai Motor Group, and they've done an incredible work in quadrupeds and bipeds for sure. I think right now we're in that R&D phase. We're still discovering architecture of the arrangements of the joints, and you're right. We definitely take inspiration from Spot and from other quadrupeds. We take inspiration, but we're more research, even in the style of academia, if you will, than whereas Boston Dynamics, which has now at this point matured their capabilities to a degree that they're really focused on productization, and both in construction, mining, industrial monitoring, and then also warehouse logistics. So they've kind of have a different focus right now. And so I think there's future opportunities for sure. But right now, because our focus are different, then we're kind of, right now we're not doing a lot right now. That said, though, I should mention the AI Institute, or the Boston Dynamics AI Institute, was formed last summer of 2022. That one, I think, as they are now forming up and starting, as you may know, they have an office in Cambridge. That one is, I think, more compatible from the viewpoint that they're starting up. They're kind of in a technology research phase. We're in a technology research phase, so I think there's a lot more of, we're in a similar kind of environment that we can do more work together. Right? One second.
Thanks for the talk. I have a question on the usage of the legs. So right now it seems like the legs for all the pictures you show, it's more of a like changing the shape and doing more quasi-static motions. Have you think about using that as a more like dynamical motion where it can jump or like hop, and how would that affect like the passenger that's taking that?
Right. Yeah. So we have thought about like kind of walking and jumping, that sort of thing, and there's the practical challenge of the mass of this vehicle is going to be not necessarily light to do that. I think from a technical capabilities, it would be great to try to do that, because then we know the range of performance of the machine can do. But then you balance that with what's the use case of that. Do you want to be jumping with like goods in the thing, right? Or having a person, you want them usually in a it's a great question, because like if you think about in a car, do you want to be experiencing this, or do you want to be like a smooth, buttery smooth ride? And I think likely you want a buttery smooth ride. In that case, then the wheels are doing all the work to eliminate the bumps, right? Bump cancellation ride technology, shall we call it, right? And then it's not really jumping or hopping around. But again, from a capability viewpoint, it'd be great to show that, because it's like, yeah, this is powerful, it's reactive, it's responsive. But I think from a use case, we'll probably have it make it more smooth, right? A magic carpet ride, I think. Yeah.
Thank you for the great talk. I have a question that says, have you tried to reimagine the wheels? That was the only part that we did not see any changes.
Yeah, we have a little bit, and there are definitely interesting wheels. But as you may know, the end effector mass, in this case, the wheel, really changes the dynamics of what we can do. And so because of that, we've kind of shied away from reimagining from the going for how do we lightweight the wheels, because they're already heavy from the viewpoint. We're going to add a motor to the wheel so they become heavier just from that fact alone. And then that additional mass, you know, when your end effector has a lot of mass, and it changes the dynamic. So we haven't done a lot except for like the question, how do we lightweight the wheel? Because the additional mass already due to the motor. Yeah.
How many directions on the wheels would change the game?
What was that?
How many directions?
Oh, yeah, it would. Yeah, it would. Right. Yeah.
I have another question from the online. So I think on a similar note to the previous question, could you expand on range considerations, fuel cell, battery pack, and how they impact the form factor, scale, and stability?
Yeah. So what's interesting about battery electric vehicles, as you probably know, they're all heavier, right? For the equivalent mass of a gasoline car or diesel car, they're sometimes a lot heavier, which is a little, it didn't, you know, maybe a little non-intuitive, but it makes sense when you start lifting a battery pack. It's like really heavy. And then obviously for liquid fuel, your car gets lighter and more efficient, the less fuel you have in it. Whereas the battery pack, it doesn't, it just stays the same mass. And so, you know, here is where I'm hoping that energy density, power density of battery packs improves over time, as it should for the automotive industry in general. That will, the more power density, the more range we'll get. We don't have a good number yet on the range. And so this is an interesting question of, given, right, in any given locomotion, rolling will be the most efficient, right? But if you have to do any kind of legged motion, that will be less efficient, right? And so we have to, how do we model that? Or how do you, and this will be interesting part, if you given a mission, right, going from point A to point B, what is the energy efficiency of that? And how well can you predict it ahead of time, you know, through mapping or whatnot? And if you don't have a map, how do you determine that dynamically as you go, right? And so there's a lot of interesting things about energy efficient pathways, given your locomotion capability and the ability of your rolling traction, et cetera. And that we don't determine yet. But the longer term, I think, depending on where battery technology goes, having the inclusion of some combustion engine could be really important, because liquid fuel densities could be remain pretty high. There's some consequences there because the additional mass for that. But we do think about what's the appropriate balance between battery and then combustion, right? And combustion doesn't have to be gas or diesel. It could be hydrogen combustion, right, as well. So still not yet settled on that question. There's a whole area of work that needs to be done there, right? Once you figured out the walking part, yeah.
You mentioned earlier reactivity and the kind of the power density problems and things like that. Are there passive components outside of like the tire itself in this system?
Yeah, what we're thinking about is a passive spring damper suspension when the vehicle is traveling on hard packed surfaces or pavement. Then we'll switch into a car mode, which would then be like a normal car. Then we'll have a passive spring damper mechanism. Beyond that, how do we? The other open question though is, even in that dynamic situation where you are using the legs, how much of the spring dampers should we include is also an open question right now. Right now, we've strictly limited it to a active serial chain. But what is the when and where should we add in passing components? And that's still an important question that we have to answer to, right? Another fascinating area of work, right? Yeah.
Yeah, hi. Thank you for the talk. My question is on the marketing side.
Yeah.
So when you are developing future seeing technologies or staying ahead of the curve, so you have the first mover advantage in a particular market, but then you run the risk of not having a very actively demanding market, and you have to like pump in money to create that kind of market, and other players can get in and have a piece of your pie. So what are the other benefits or drawbacks you have when you are like targeting a new market or creating a new market? So, and how do you guys navigate that? Thank
Yeah,
you.
yeah, it's a great question. How do you like we have a new product, so new customers, and how do we navigate that? Because then obviously if you have no customers, then what do you do, right? So we have to create customers at some point, and so my thought is the following: is that if you begin with this might sound kind of funny. If you begin with the need, we'll never get there. We'll never have enough of a market, right? Because needs are like, because when you have a need, then there's always a counterexample of either the need goes away or you have a way of working around the need, or you can solve the need a different way, right? And I think you're probably thinking, if you're thinking life, there's probably a lot of things in your life like, you can ask the question, ask yourself, do I need it or do I want it, right? You need it, and you're like, well, do I really need it? Or can I just forget about that and not need it anymore, right? Or is there something that kind of works around in a way that I can satisfy the need? On the other hand, if you start with a want, right, then you will have, I think, a better chance of being successful in the market. Because when you have a want, at that point, it's a want. You'll acquire it through the means that you have available to you. And the best example that I give all the time, is a smartphone back maybe 12 years ago, 13 years ago, if you can remember that, right? 2008, 2009, let's say, right? At that time, we have flip phones, right? But how many of you have a flip phone, right? Okay, we have three, okay, right? which is right, but it's the vast minority, right? At this point, a smartphone was a want, right? Back maybe in 2009 or 2010, but it's much more of a, I mean, it was a, maybe, yeah, it was a, what was it? It started out as a want, so people bought it, right? Now it's a need, right? Now I need a smartphone, right? Because in other words, it's for the 95% of us, we're going to buy a smartphone because we think we want it. We need it, right? And it's kind of true, right? Banking, Uber rides, hotel, mobile key, my music, notes, presentations, they're also on my smartphone, right? So for us, like, how do we generate the want of our vehicle? And that is the thing that we haven't figured out yet exactly. How do you create a want of this? But my clue comes from what I mentioned early on, is through story and science fiction. Both of those are means by which you can convey kind of emotion and sort of not plausibility, but like the vision of it, right? So Star Wars is a great example of the use of droids in our lives, right? It was interesting research, just like, or an article just like last week. They actually compared C-3PO and R2-D2, and like the majority of people want an R2-D2, not C-3PO. That's the other thing too. Like with storytelling and fiction, you can use that to help you with the design. It's like, do I do a biped or I do a rolling three-wheeler, right? In this case, the rolling three-wheeler, right? People are less interested in a biped for some reason, right? Uncanny Valley and all that stuff, right? So long answer is like, we have a big challenge ahead of us to create a want. How do we tell that story? How do we convey the use that people will recognize the value of a UMV and then therefore want it, and then later on need it, right? Yeah.
I actually have two questions. One is on the technical side and one is on the marketing side. So my first question is, so obviously you've talked about the high energy density requirement of electric vehicles, but how about the output of the energy cells? Because removing already there is a requirement for these cars to go fast, and the cells are not able to provide this high density of output. But now if you're talking about moving 800 kgs of motion and with 12 motors or so, let's say, then how are you going to add the number of cells required and also have the efficiency and all of that? Have you thought about that?
Yeah, we definitely have thought about that. And so speed is definitely going to be a careful consideration. Some of the use cases that we have in mind are with people, right? So people, maximum speed of a human being is about 25 miles per hour, but that's only for like 10 seconds or 15 seconds, right? And that's an elite human being. Someone like me, if I can do 5 miles an hour, that's a good day, right? So the vehicles don't have to move that fast in the cases where it's a collaborative, mobile, autonomous machine. Now, in the case of it being a highway vehicle, then of course that's a different story. But I imagine a lot of the use cases are with and around people moving at human speeds, and so the power requirement will be lessened. Now, the other question though of mass payload capability, that is an important one that we have to be very carefully designing the degrees of freedom and when and where it does that particular articulation, right? And I think one of the things that helps, like if you don't have to like lift and lower the leg, that actually helps a lot. And if you're just providing this adaptive suspension functionality, then it's a lot of energy because it's still like humans. If you're doing this all day, you're gonna get tired. But hopefully we're gonna try to design it so that we can, hopefully optimize how much energy that we're using, right? Power. That's a great question.
Yeah, for my second question, so it's about on the marketing side. So actually you referenced about iPhone, right? Before iPhone, there was a company called Palm Pilot, which was the actual innovator of like the ideation of what an iPhone should be. So they were too early to the market because technology could not catch up.
Yeah.
So it's kind of almost a similar situation because battery technology should catch up to where you're trying to innovate to. So how do you see yourself navigating this over the course of the next few years or decade?
Right, and so this to navigate like the market appropriate location would be it'll be a process of discovery, and as I talked about for a little bit of storytelling and of the kind of visualization actually through a short film, right? To kind of put out there an idea, and just like movies, actually I think movies are really good, or like short films today, like even like on YouTube, right? The ones that kind of resonate, they have more clicks. Right? And so if we put out a series of short films, the one with the most clicks will likely be an indication of where there could be both an attraction of the want or the need, and then the use case that we can then say, this, and it doesn't necessarily mean that it's going to be sufficient, but it could be provide an important signal as to what that might be. And so it is tricky, right? Because being ahead of in business, being ahead of your time is not good, right? In research and academia is probably a great thing, but in business, being ahead of time is, you never want to be said, I was ahead of my time. It's like, that means that's code word, like your business failed, right? Right. Thank you.
Mark, are you calling me back or do we have time for one more?
So, great talk and fascinating device. I'm very curious. Have you what is your imagination for the user interface? Like, if you're driving this thing and you need to go off road, like, what do you do?
Yeah, yeah. My vision for the interface is, my inspiration is a horseback riding. The interface is a rope. That's it. Rope, and then your legs, your thighs, and then like other animals, horses respond to verbal cues, right? So, is that? Yeah, basically. But hopefully, interaction is like the way you interact with your pet dog, pet cat, or horse, right? I hope it's like that, right? It's like it knows your body language, knows your cues, knows your voice, and it reacts, right? So there's a lot of the subtle autonomy. That's why this collaborative mobile autonomy, there's a lot of subtleties there but I think it's a really rich area. That's why I call it kind of synthetic reanimation, right? So how do we, and I think that would be great, right? So there's no screen, right? There's no screen on this thing, right?
All right, thanks, John. Super exciting, lots of very interesting problems to look forward to. Let's give him a hand one more time.
Thank you. Thank you.
Okay, so please tune in on Friday, March 31st at 10:30 for our next Grasp on Robotics featuring Pulkit Agrawal from MIT. For more information for our upcoming events, be sure to follow us on social media and check out our website.